I would like to welcome Geoffrey Killen here to speak to you today, and he's now going to go ahead and tell us about ancient Egyptian woodworking.
Thank you. There won't be any graphic illustrations of blood unless I actually cut myself today, so in this presentation, I would like to examine the materials that are available to the ancient Egyptian carpenter, the tools and techniques he used to work them. Now, the timbers that he used, I think probably acacia is one of the most prevalent materials. It's a very hard and durable timber. It was worked into furniture and used to make chisel handles. And acacia coffins, bows, dowels and pegs would be found, and it was widely used in the boat building industry, it being a native timber. Another native timber was the sycamore fig, which is recognised by its massive lateral branches, and it produces a very pale timber with a coarse grain and is often of poor quality. Nevertheless, it was used in general woodwork and in the manufacture of coffins and general woodworking. Now, in the mortuary temple of Queen Hatshepsut are punt scenes which show Egyptians and Africans cutting branches, what was from thought to be African ebony. Now, the tree that they're cutting is not the truly black Diosporus, but Dalbergia. And Dalbergia is a very hard, dark, black to brown coloured timber. Now, with demands for better quality timber, the coniferous wood trade from regions north of Egypt was well established by the 4th dynasty, and the Palermo stone records that during the 4th dynasty, boats were sent to the Lebanese coast where trees such as cedar were actually felled and were rafted and towed across the Mediterranean to be stored in timber yards in the delta. The Lebanese cedar, and this example is in the Cambridge Botanic Gardens, is a very large tree growing to between 30 and 40 metres in height, with a trunk of between 1 and 2.5 metres in diameter. It is a wonderful timber to work, for it has got straight grained, it takes a good polish, its colour is a pinkish brown colour, it's very durable. It was widely exploited, and many of the pieces of furniture that were discovered in the tomb of Tutankhamun were made from this timber. Now, the care in which timber has to be felled, so preventing the possibility of splits or thunder shakes developing or impacting into the grain, is seen in a relief found in the northern exterior wall of the hypostyle hall at the Great Temple Amun at Karnak. And here we see a scene that shows woodcutters felling a tree. One man is using an axe at the base of the trunk, while 2 others are holding the tree with ropes, which have been tied to the uppermost branches. And by doing this, it allowed them to actually control the speed and direction of the fall of the tree to the ground. Not only is felling an important process, but also the conversion of it has to be done promptly to prevent defects such as shakes developing. Now, these are splits that open into holes either radially from the centre of the trunk or around the growth lines. And the technique of cleaving timber was well understood and practised as early as the pre-dynastic period. And we do find examples of crudely constructed burial boxes made from irregular shaped planks that were pegged together. And an experienced craftsman could split the trunk into quite thin planks with ease, and we can establish that the trunk has been split by following the lines of cleavage which follow the grain through the tree's rays and through its weaknesses and irregularities. Now, those native timbers commonly used in the pre-dynastic period would have been worked with simple flint knives, some of which had their cutting edge serrated very much like a primitive saw. At this period, there was little demand for imported timbers. This changed dramatically with the introduction of specialist copper woodworking tools during the early dynastic period, and we can see these tools being used in the tomb of Saqqara. This new technology created opportunities for resistant materials such as timber to be worked with a high degree of accuracy, and a fine collection of First Dynasty tools was discovered by Professor Veneering at Saqqara in 2MS 3471. Now, with one of these tools, the copper handsaw, it became possible not only to convert timber into boards, but to cut these to various lengths and across the grain to form sophisticated cut joints in the timber. Now, these saws were developed initially from the profile of the knife, and they were between 250 and 400 millimetres in length. In ancient Egypt, timber was converted by using a saw, with the log being bound by rope to a vertical sawing post. Therefore, accurately sawn lengths of timber were not normally greater in length than the height of the sawer. And the majority of these scenes show that the timber was converted vertically against the post, which was fixed firmly into the ground and occasionally held upright by taut guide ropes attached to the top of the post and fastened into the workshop floor. The conversion of green timber, the term indicating that the timber has been freshly felled and there is sap still trapped in the cell cavities and walls, would have caused the kerf of the saw, the actual cut and the blade of the saw, to actually stick. And what we do see is a lever mechanism passing through the strapping to tension the strapping, very much like a tourniquet. And whether this stone-weighted lever was actually fixed into the kerf, which is the saw cut, or just held the plank firmly together against the sawing post is uncertain, although it certainly appears to have been discarded as a technique by the New Kingdom, which suggests that the saws had different types of set by the New Kingdom. The teeth were arranged differently. Now, the process of reducing the moisture content of green timber is called seasoning. And planks which are prepared by through and through cutting shrink more on the face which is furthest away from the pith than the centre of the tree than the face that is nearest the pith, the centre of the tree. Therefore, when planks dry, it is an important process, because if they dry too quickly, then the plank will cup or warp. And to properly season a piece of timber from the time it's cut to the time it's actually used, for a piece 25 millimetres thick would take about a year. So it's quite a slow process to actually season the timber. Now, some timbers, for particularly statues or panels, may have been radially cut, and that's cut down the tree's rays, and that's the way that the timber would have been cleaved as well. And this time, when they dry, the wooden element, because it's been cut at right angles to the growth lines, shrinkage is on both faces of the board and is equal, and the board is unlikely to warp, although it may actually shrink and swell. Now, by the 5th dynasty, the handsaw had evolved to have a straight back. It certainly was not the profile of the knife any longer. It is a woodworking saw, and it was designed with a moulded handle. And this is seen in quite a remarkable set of woodworking tools that are actually preserved in the British Museum. However, the pull saw was exclusively used to convert green timber by ripping down the long grain. It's a much longer saw. Its teeth point towards its integral metal handle. It has a straight back with a pointed nose, and was used with both hands. The sawer pulling it down at an angle through the timber. The size of the teeth are much larger, and the pitch, which is the distance between each tooth of the saw, is greater, which made it a very efficient saw to rip down timber, down the length of the timber. The adze was used to true and shape timber. The Egyptians didn't use a plane, but they used adzes. The shape of the metal blade developed considerably throughout the dynastic period, and it's during the early dynastic period that the adze shaft was straight. However, by later dynasties, as this example shows, the smaller of the adzes, they were manufactured with shaped shafts. And They were also manufactured in a variety of different sizes. Small examples were used to shape wood, while larger adzes were used to remove the bark from timber and to true timber after it had been converted. And during the pre-dynastic period, we find the evidence of small copper chisels. And these were used very much like our modern cold chisel. They hadn't got a wooden handle, and they would have been hit and repeatedly struck on the end with a hard implement in order to cut their way through timber or other types of resistant types of materials. And these small chisels would have made the holes that you see and grooves that you see in many of the first dynasty or pre-dynastic burial frames. Now, by the early dynastic period, carpenters used both mortise and firmer chisels. Now, the mortise chisel is illustrated on the left. It has a square stout blade which is fixed into a large cylindrical handle which has a flat top. That's useful because the blade is rather thick and stout, so you can prise chips of wood out of deep holes that you've cut into the timber. The firmer chisel, on the other hand, the one on the right, is a much longer handle, a shorter blade, and the blade at the bottom has a flared cutting edge, which shows that it was actually used for cutting and used with handwork rather than being used with a mallet. Also discovered by Emery in Tomb S3471 at Saqqara were some thin blade awls which could be used to bore holes in timber. Now, all these tools would need to be sharpened at regular intervals, and the carpenter's workshop was equipped with a small forge where blades could be reformed and heat treated, and the final cutting edge would have been ground onto the blade with a hone in a process very similar to what we do today. And as you can see, this is a hone. Along the hone are lots of lines that show that the cutting has actually taken place, and a few scrape lines across the hone which show that the burr that actually forms on the edge of the cutting edge has to be removed by turning the blade over. You can also see there's a hole in the hone as well. To help lubricate the hone, oil from a flask was applied to the surface, and at one end of this particular oil flask we have a wooden stopper, and at the other end we have a spoon or a spout. And tied around this particular oil flask, what we have is some cord which indicates that it would be hung in the workshop with the hone. Now, in the tomb of Veneering at Thebes are illustrations which show carpenters at work in a joinery workshop. This scene shows the importance that carpenters placed in the measuring and setting out of timber. He uses a straight edge or cubit rod to measure and test the timber element is true, and he also uses a tri-square. And we also see this tool, which is a mitre square, which allowed him to actually cut 45-degree angles onto timber so he could actually mitre frames. Now, only recently we have actually discovered in the Petrie Museum an example of a mitre square, and that's the only example I know of that we have many tri-squares, but that's the only example I know of a mitre square. Now, the first illustration of the bow drill being used is again in the 5th Dynasty tomb of T. Now, although it must have been used earlier to bore the large holes that we find in the legs of bovine-shaped bed frames. Now, when finishing and smoothing timber, carpenters used, as we do, abrasive materials such as sandstone. We use sandpaper, but they can be seen correctly using these abrasive blocks and rubbing the block along the grain. Now, this process was used throughout the dynastic period and is illustrated in the Old Kingdom tomb of T at Saqqara, as we can see here. Now, Egyptian carpenters also began to experiment in the lamination of timber and making thin sheets of timber as early as the 3rd Dynasty in an attempt to fabricate a large sheet of material which was dimensionally stable and equally strong in all directions. Because you're limited to the size of the plank, if you need a larger piece of timber, you have to edge joint it together, or you create plywood. And Egyptians did actually experiment and manufacture plywood. This is an example of 6 plywood, where the grain of one piece of timber is at the right angles to the next. And this was discovered in a sarcophagus in the Step Pyramid at Saqqara. Now, probably the most commonly used joint that you find in the pre-dynastic period was the butt joint. We find that many pre-dynastic burials have the body placed on a matting made from plant fibres and twigs that were supported on roughly shaped poles that are butted together. And we see the use of the butt joint is always held at this particular time with some type of mechanical fixing. Egyptians discovered very early on that they could not use glue on the end surface, on the end of the grain, because the glue would be absorbed into the actual grain and you would not get a satisfactory line of fixture. So what we find are butt joints tied together, pegged together, but never glued together. We also see the use of edge joints, and this particular type of edge joint would have been used to make boxes, or to make the panels of boxes, or the bases of boxes. And again we can see that the timber has been drilled on both surfaces and is tied together with either rawhide or some sort of linen. Usually dowels or pegs were used to secure the joint, and sometimes we also see that some joints were actually fixed with what we call loose tenons, either without the method of fixing or with the method of fixing, dowels being drilled, holes being drilled and dowels being placed into the actual loose tenon to build the construction of the object. We also see how this actually works on this particular box, which is in the Tomb of Purport, came from the Tomb of Purport, which is in Durham, and we can see that we've got 2 irregular shaped panels of timber that are edge jointed and then secured with floating tongues that are actually doweled together. Here we have some edge joints on a burial box, but the drilling is not very good, and what we can see in the centre is the drill hole the hole is actually broken through, and the dowel has actually fallen out of the actual box. But that is made from 7 thin slats of timber that are edged together and doweled together. Also, if you needed a curved surface, you would have to employ what we call the Cooper joint. And the Cooper joint has the angled surfaces slightly angled, so when you bring it together, you can then form a curved surface. And that was used in the construction of that small box that was discovered in the Tomb of Tutankhamun, and the surface of that was actually then veneered separately to give the impression that it is a solid surface that is curved. Now, the first formed joint is the lap joint, and we also know it as the rebated butt, and examples of this type of joint can be found as early as the pre-dynastic period. This type of joint could be glued. And the partitions of boxes show that the carcass of the box was actually connected what we would call with a housing joint. On many model boats, we see the jointing of the boat showing that they're using a joint which we would call the halving joint, where timber is removed from both pieces of the wood in order to create an angle. And it didn't have to be a right angle, it actually could be any angle really. And we also see a similar sort of joint here in the centre, which is a triple joint. And this is on a var stand that supports and strengthens the 6 legs of that particular product. Now the blade of tri-squares were connected by another type of joint, the bridle joint. And this particular example dates from the Ptolemaic period. The joint is held with a pair of of metal pins, and there are wooden wedges carefully wedged into the joint to actually enclose an accurate 90-degree angle, which was important for the marking and setting out of the timber. Now, the family of joints which make the mortise and tenon joint were extensively used in ancient Egypt by joiners, carpenters, builders and sculptors. And the common through mortise and tenon has square shoulders, as seen on this slide here. Has a tenon that is taken completely through the opposing rail and can be found, this type of jointing structure can be found on simple bed frame stalls and chair constructions. This arrangement, however, prevents the seat rails lying in the same horizontal plane. And again, the way that these joints would be secured would be wedges would be driven into the cheeks of the joint, so supporting and strengthening the joint. The common through mortise and tenon with scribed or curved shoulders was also found at Takhan on bed frames which are supported by bovine-shaped legs. The curved or scribed shoulders below the tenon, which projects from the top of the leg, mould around and support the side poles of the bed frame. We also see the same type of joint used on folding stools that have the ends of their diagonal spindles formed with goose heads. The tenon projects as the goose's tongue and is mortised into the floor rails, and the beak forms the scribed shoulder of the joint. And there we have an example that is from Liverpool. Now, to allow the seat rails to lie in the same horizontal plane, which allowed the actual seat to be properly manufactured, we begin to see by the New Kingdom that carpenters began to halve the thickness of the tenon. And again, the practice of wedging the actual tenon rather than using glue is shown here in this slide. And where the cross rail is thinner than the stile, we see that Egyptian carpenters prefer to use either a bare-faced tenon without shoulders, or alternatively, as in this slide, we can see a bare-faced single-shouldered tenon. Egyptians also used stub tenons and mortise joints, and had applications on stall and frame construction where the mortise is stopped and that's not chopped completely through the stile, and it can be found here on the back support of chairs. Now, usually this joint is used by is secured by a single dowel, which you can see there, and you can't wedge it, you can't really properly glue it. And when you find examples of this type of joint, if you look in the bottom of the actual mortise itself, you can see across the mortise lines left by the chisel as the chisel was actually cutting and chopping down into the timber. The dovetail joint, which has tapered towels on one element and locates in a matching socket on the adjoining piece, has been identified on fragments of ivory discovered in the royal tombs at Abydos. And the roof poles of the bed canopy of Queen Hetepheres that is in the Cairo Museum with a copy in Boston, is actually the roof poles have actual dovetail joints that secure it to the posts on the top of the frame. The main use of a different type of dovetail, the lapped dovetail joint, is in carcass construction. It's seen here is a wonderful example of a lapped dovetail, which is used on a drawer front from a 12th dynasty box, which is preserved in the Metropolitan Museum of Art. Now, the earliest examples of simple plain mitre joint have again been found connecting the corner boxes of burial boxes made during the pre-dynastic period, and the process of jointing the end balls to form boxes and coffins could be achieved with a number of different types of mitre shouldered joints. We find, firstly, on coffin construction during the Middle Kingdom, we find the use of the single shoulder mitre. We also find the use of the double shouldered mitre. There are other variants of this type of joint. We have the butt surmounting a plain mitre, and also a dovetail supporting a plain mitre. So large variations of different types of mitre joint used during the Middle Kingdom. Now, because Egyptian timbers were quite short, this was because of the conversion process. The common scarf and butterfly cramp locking mechanism was employed to fasten lengths of timber together to make them longer, and the faces that come into contact with these are cut at an angle, and then a double dovetail socket was cut across the splice, and into that socket was actually driven a butterfly-shaped wooden cramp that secured and locked the battens together. We also find the use of a scarf joint, and this was used to join shorter battens together and to make longer rails. And in the boat building industry, we find the use of the scarf joint that is tied together. And if you've seen the boat, Khufu's boat at Giza, you can see quite wonderful examples of that type of jointing structure there too, one at the top and one at the bottom. Now, one thing I'm particularly interested in is the art of rotating timber against fixed centres and scraping the wood away. And was it a known practice to the Egyptians? Because it's always been considered that wood turning is actually a Roman invention. Now, there is apparent evidence of small-scale turning that can be found on a few stool legs that date to the New Kingdom. Now, the first illustration that we have of turners working a lathe can be seen in the Greco-Roman tomb of Petosiris at Tunagilbu. The wooden bed of this lathe appears to have been mounted vertically and mounted into the workshop floor. Now, this wall relief possibly has been rendered in this way to give us the impression of how this particular piece of machine equipment would have been used. And more likely, as the example that I will be demonstrating shortly, it probably was actually mounted horizontally. And such lathes do exist still in places such as Afghanistan. Now, the majority of round legs that you find on New Kingdom stools are neither turned nor handwork between centres, pivoted between fixed centres. They are irregular in profile and not circular. They show no evidence of being supported between centres, and those lines which are incised around them are uneven. The shoulders are not machined square, and there is a spike that protrudes from the top of the leg that is jointed into a roughly cut hole in the underside of the seat rail. Now, however, saying this, and the majority of stools that we see are hand-worked, there is a small corpus of material which have been carbon dated to the Ramesside period, which do show, as in this particular example in the British Museum, that they do display characteristics that are quite similar to being turned on a lathe. Firstly, we can see in the bottom there is a pivot hole. So at some stage the piece of work was actually held against the pivot to rotate it. Now, one particular example, which is in fragmentary form, allows us to look at its construction in more detail. From the top of the leg to the stretcher joint, it's been worked parallel and then smoothed with sandstone, and below the stretcher joint the leg has been scraped, a form of turning, into a very simple spindle shape. The parted surface in the centre here, would have been scraped away with a fairly wide bladed chisel. Now, We do have examples of wide blade chisels. So they cannot be identified as a mortise chisel, they cannot be identified as a firmer chisel. And this particular example is preserved in Durham. And what I've actually tried to do is replicate, using a lathe, the use of that type of chisel to create the type of scraping marks that you actually see on a limited number of pieces of furniture from the late New Kingdom. Now, some researchers, it is controversial, some researchers have argued that wood turning in Egypt could not have occurred until the use of iron was well established. Now, when you look at the examples I've cut, this is 100 times magnification of the timber that has been removed. You can see that the samples are the same width as the blade, and they have been torn from the surface of the timber. Now, although people say that there was no iron used in the New Kingdom, there are model examples of iron tools discovered in the tomb of Tutankhamun. They come from meteorites. And so what I've tried to do through the experimentation is to take a meteorite and to heat it and to forge it into a chisel that is comparable with one of the model chisels that was discovered in the tomb of Tutankhamun. I will be demonstrating that particular tool shortly. Now, when we look in collections, deep into collections, we find interesting pieces of material. And this is a spindle from a collection of the School of Archaeology, Classics and Egyptology at Liverpool. And here we can see quite clearly the end of a piece of timber, and deep inside the pivot there are burn or scorch marks, which certainly indicates that at some stage during its manufacture it was actually rotated at speed on a metal pivot. To embellish timber, carpenters began to look at ways of creating veneers, which were cut with a thin blade saw, unlike the modern process of slicing or rotating the material against a fixed knife. And we find large amounts of ivory strip incised with twisting, crossing, diagonal, zigzag patterns, and been discovered at a number of early dynastic sites, and were always dowelled to furniture in an early attempt to veneer it. And many of the boxes that were constructed during the New Kingdom had their panels edged with ebony veneer in an attempt to give the impression of a rich frame. When looking at this, you would think that there is a frame around the outside, a batten across the middle, and then two separate panels fixed. It's an illusion. It's just two solid boards. The whole surface has been simply veneered with materials and glued down. So these are strips of ebony, a comb pattern of tiny pieces of ivory and ebony, and then pieces of ivory and faience actually glued down onto a solid surface. If you turn the lid over, it's a solid board. During the 18th dynasty, we do see carpenters such as this one in Rick Mire's tomb, and showing how the carpenter applied hot glue with a brush to a leaf of veneer. And the glue would be made by boiling down the bones and skins of animals and allowing the concentration to evaporate, which made it into a very viscous adhesive solution. Now, the technique of inlaying, that is embedding materials into wood, was also widely practiced as from the early dynastic period. And here we see an example of a piece of faience that has been actually inlaid into a wood fragment from a bidos and actually carved with a bound rush pattern. And on a number of pieces of timber that were discovered from the tomb of Tutankhamun, we also see the examples of marquetry and parquetry work, where one particular box was covered in a herringbone pattern with something like 50,000 individual pieces of material. We also see boxes were actually painted on ivory or stained. We find the application of gilt used to cover timber, and also the use of thicker gold sheet, as in this example, that was sometimes beaten around the wooden cores and then punched and pressed into shape and then held with small gold tacks. And in the tomb of Meket Ra at Thebes, we have a wonderful illustration through this carpenter's workshop, which shows some Middle Kingdom carpenters, and they're shown engaged in many activities: truing wood with their adzes, converting the timber, mortising with their chisels, and converting timber with a pull saw in the centre of the workshop. At the back of the workshop, there is a chest in which the tools would have been stored at the end of the shift. And also, in the corner, a forge, where the tools would have been heat treated to retain their hardness and where they would have been sharpened. The New Kingdom carpenter used an extensive range of woodworking tools, which we know were held in like a holdall. And the quality of work that he produced was very fine, and he was skilled in many, many processes. And these processes and techniques of working wood that were developed in antiquity are still used today and by today's carpenters, and have been passed down from master to apprentice and continually practiced through the last 50 centuries. Thank you. Right. Now, have we got some helpers? Young, fit helpers. Now, come on in. Right. I just need a hand. I don't know if you want Neil. Can you Neil? Yeah, Neil. Right. Okay. The saw. This is based on the First Dynasty. Its teeth point towards the handle. Its curve is that each tooth is punched on the blade in one direction, which is unlike a normal saw where the kerf has every alternate tooth punched in one direction then the other. Now, doing that allows the saw to have a wide kerf, which allows the sides of the blade not to come into contact with the surface of the timber. Now, this saw doesn't, the Egyptian saw doesn't, and it's quite a difficult saw to use because of the teeth pointing in the same direction. The saw wants to go in the direction of the teeth, and so when you're sawing, you tend to find that the line is drifting away from the line that you want it to cut, and you continually have to tweak the line. Now, the saw is very much like the Japanese saw that the Japanese still use today, but it is an efficient saw. So a copper saw, a piece of timber, the block is important. It's cut with 2 rebates on either side, so it can be used by a right-handed person or a left-handed person. But it does give you the opportunity to hold firmly. You never have vices, they only have these blocks, to cut quite easily, as good as a modern saw. We can cut quite easily with this type of saw. Another tool that the Egyptians used was the adze. Now, the adze is attached to the shaft with leather ties, and it would have been used by trimming down, okay, Also, they may have used it this way. And by doing it that way, you're actually using the adze very much like a plane. But the thing is, there are no planes in ancient Egypt. The technology is simply to reverse the blade and to hold the blade in some sort of container to keep the angle that you need to attack the actual piece of timber. So the adze is an important tool, and so are the mortise and the firmer chisel. Here I have a mortise chisel and its mallet, and by chopping through the timber at right angles to the grain, you will progressively get a mortise, a hole that either can go right the way through, a through mortise, or a stop mortise. And when you look in the bottom, you see, you get the same pattern of cutting as you would actually get, as you saw on those bed frame poles that came from the Middle Kingdom site at Beni Hassan, but always cutting across the grain. If you try to use if you try to use the mortise chisel, okay, along the grain, the actual timber would split. So they understood quite clearly the mechanical properties of the timber, and they exploited these mechanical properties in order to be able to create frames and the artefacts that we see today. One of the tools that possibly is the predecessor of the lathe is the bow drill. And here we have an example of the bow drill. We also find the bow being used to light fires, so it could also be used as a fire drill, or to make fire. Start the hole off. This is the two-person. Yeah. Start the hole off. Take the drill. Place the drill upside down. Turn. Then we need a cup, some type of cup that is lubricated, into the hole. Cup on the top. What you would do is you would bore a hole. Okay. Drilling halfway into the block. But you can see, yeah. Material would have been ground back with abrasive blocks, just like we use glass, paper and cork blocks. So they're the main woodworking tools that the Egyptians used. And using these tools, I've been able to manufacture things such as the headrest and examples of the Beni Hassan stool. And we can see here the seat rails will not lie in the same horizontal plane because of the joints are staggered. And also attempted and manufactured in preparation for sort of making folding stools. This is an example of a goose head with the tongue that projects, and this is just to get the technique right before we're actually manufacturing the complete object. Now what I'm going to do now is I'm actually going to demonstrate the lathe, and that will be perfect for timing. Okay, so what I need to do, have you any heart problems? Good.
I'm allergic to hard work, right?
Oh right, well you're not going to... I'm going to sit over here. I'd like to sit on the floor. Okay, sit right on the floor. That's it. Okay, put your feet 1 foot against there, 1 foot against there.
On the top, or?
Yeah, no, on here. That's it. Right, good. Hold the rope. Right, hope everybody can see. Right, okay. Put some pressure on. Harder. Okay, right, that's right. That's right. Right, then this is a very strenuous process. Not for the turner, though. Now, I think no more than about 4 minutes. Then you would have to stop. So you would be young and I would probably be old. Okay, right. Now, I don't know if we can see this, but we're going to attempt. Now, because it's a reciprocating lathe, the cutting stroke is always going to be on the stroke coming towards the chisel. But half the time, the work is going the other way. So you have to develop a sort of, with the actual turner, you have to get into the rhythm of cutting on the forward stroke. Yeah? Okay. And I guess it would take some time for the two of you to get into the swing of it. Yeah, that I'm going to cut on the forward stroke. So if you, and also on the forward stroke, that's the stroke coming towards me, you need to put more power. Okay, so come try that. And that's it, marvellous. Right, I want lock. No, you've got to keep the tension on. Take a rest. Exhausting. Exhausting. All right, now this is the type of lathe that you see in the tomb of Petosiris. And so it is a very difficult process, but they were using this process to manufacture a variety of different artifacts. Chairs, stools. One more go?
Sure.
One. Try not to make it slip. And big pulls. Thank you very much.